For this tutorial, I have invited Wolfgang Spahn to collaborate on interfaces powered by the human body. The tutorial introduces two experiments presented in my toolkit Ultra Low Voltage Survival Kit. The toolkit includes components for building circuits for audio-visual performances that use our bodies as a replacement for energy source. The project proposes to reconsider properties of human body that could become an essential source for powering up bionic implants or external devices.
We generate a little bit of energy with the reaction of zinc and the human body, similar to a battery, and power a LED with that. And in the second experiment, we use the body temperature, precisely the temperature between the body and the environment, to generate energy. And with that, we power an audible synthesizer that is controlled by temperature and light, and with the sound modification we can create a biofeedback.
In this experiment, we built a circuit for LED lit up by a human body. The circuit uses a self-oscillating voltage booster, also known as a joule feed. For the circuit, we will use following components: a breadboard, a 2-wire coil, 2 electrodes, one copper and one zinc, a transistor, a resistor, a white LED, jumper wires, and 2 alligator clips.
Push the transistor provided into the terminal strips with the collector leg on the left side and the emitter leg on the right side of the breadboard. Each of the 3 legs of the transistor should be allocated a different terminal strip. Push a coil into the middle of the breadboard left of the transistor, so each of the 4 legs of the coil is allocated a different terminal strip. Take a jumper wire and connect the bottom left leg of the coil with the top right leg of the coil. Connect the bottom left leg of the coil with a power rail on the breadboard. Take an LED and push the long leg into the terminal strip with the bottom right leg of the coil, then push the short leg into the empty strip on the breadboard. Connect the short leg of the LED with the top left leg of the coil. Connect the collector leg of the transistor with the long leg of the LED. Connect the base leg of the transistor with the short leg of the LED. Connect the emitter leg of the transistor with the ground rail on the breadboard. Take a 10 microfarads capacitor and push its long leg into the power rail and its short leg into the ground rail. Take a copper electrode and connect it to the power rail. Then connect a zinc electrode with the ground rail on the breadboard. Use the alligator clips provided. Take both electrodes in your hands. If the circuit has been connected correctly, the LED should start blinking. For further experimentation, try to replace the copper electrode with graphite, for example, and the zinc electrode with aluminum. Other variations are also possible, including the use of a potentiometer instead of a resistor, a Peltier element with an additional joule thief provided, different coils, and capacitors.
We want to introduce and show how the symbiotic synth works. It's a small synthesizer I designed that runs and is powered by the body heat, or precise the heat difference between the body and the environment. For building the circuit, we need, beside of the circuit board, a lot of parts. So it's a quite easy circuit, but we need some resistors, and a lot of capacitors because we have to store the energy we produce, and for that we have some 220 microfarad capacitors and then some smaller ones. Then we also need some capacitors for the oscillating circuit, and for that we need 2 transistors as well. And the core, or the most important part, is a small chip, an LTC 3108. That is a chip, it's a DC-DC converter. The point is, the Peltier element makes just a tiny little voltage. And to run a circuit, we need at least 1 or 2 volts, so we can run some semiconductors with that. And to step up this little voltage we generate, we need this DC-DC converter. Unfortunately, it's an SMD part, so we need a small adapter board for that as well. In combination with a coupled inductor, 1 to 100, it will boost up our voltage to around 2 volts. And with that, we power our oscillating circuit. A potentiometer is needed too for adjusting the frequency. All parts are on the list. The parts where we have to check the polarity, it's on the manual as well. So for the LED, we have to be careful with the polarity, certainly the transistor, and the electrolyte capacitors need polarity as well. Together with a headphone, I used one from an airplane, so it has these 2 mini jacks. Together with these 2 sockets, we can build the circuit.
Use your skills in order to build a circuit depicted on the sketch, figure number 8. For further details, please refer to the website or print a PCB sketch for a strip board provided.
The electricity is boosted up to a higher voltage, and with that voltage we run a small oscillator. And with that oscillator we can listen to that, and we can change the frequency and the sound depending also on some sensors. I first want to demonstrate it. So I just plug in the Peltier element, and I can run the circuit on a test status. So the LED should light up if I generate enough heat, or my heat generates enough electricity. So hard to see, but now the LED lights up. If I switch it to the audio mode, I can connect a headphone to it and listen to a synthesizer sound. That sound I can change with the potentiometer, the frequency, and I also can add some sensors for modifying and make variations of the sound. Because it runs on the headphones, I want to demonstrate the oscillation with an oscilloscope as well as an amplifier and a speaker. For that, I connect the probe to the device. And here now you see these peaks. Then is the oscillation of the circuit, and yeah, you can listen to it as well. And when I take my hand away, you see the frequency decrease. That means the circuit won't generate any more electricity. So it will stop working, and in the moment when I heat it up, it starts to oscillate again. And like I said, you can listen to it with the headphones. If for demonstration purposes, I brought a small speaker so we can listen to that. So as the same, I will connect that to the circuit.